So the speed of light is miles per second. How many meters per second?
I don't know the conversion.
Well, you could just Google it.
Well, that's
And I'll tell you whether it's right or not, because I have these in my head.
299,792. Oh my god.
299
Is that million?
1,792,458.
So it's 300,000 kilometers a second.
Yeah.
Yeah?
Wait. Oh,
300,000 kilometers a second.
Yeah.
Okay, so you guys understand what a light year is?
Yes, it's how long, wait.
No, we started, the first word was good, how, but the second word we need to change.
A light year
It's
is
not a length.
a unit of length used to express astronomical distance.
Astronomical distance. Or
It's how long it
astronomical
takes,
unit.
light to travel from one place to another.
Yeah, it is. And that length of time, because light travels at a speed,
Is the length.
you can take time and speed. Speed is distance per time. And you can multiply that by time. So you can take distance per time and multiply it by time and cross out those, cancel and get distance. So what I would like to say to you is I'm going to show you how far a light year is using the speed of light. The speed of light is 300,000 kilometers per second. And because we need to figure out how far this goes in a year, don't write it, just watch, okay? We need to change seconds to years. And that will give us the number of kilometers that light travels in a year. So if it travels that far in a second, we could change it to minutes. And if I wanted minutes, I'd put that on the top and I'd have seconds on the bottom, but that's not gonna work, is it? No. So what we do is we put seconds on the top and minutes on the bottom, because that way the seconds will cancel, and then I'll get distance per minute. And that sounds good, right? Okay, so how many seconds are in a minute? 60, so I use 60 and 1 because they're equal to each other. Let me keep going. Now what I want to do is change my minutes to hours. And we know the relationship between minutes and hours. In 1 hour there are 60 minutes. By doing this, my minutes will cancel, I'll be left with hours. So every time I write another fraction, I have to have this idea of these units being the same on the top and the bottom so they cancel, and the units I want end up on the bottom. And eventually I'm going to have years. So how many hours are in a year? I don't know, but I know how many hours there are in a day. Whoops. So I'll put hours on the top, I'll put days on the bottom, and one of those is how many hours? 24. Now I don't know how many days there are in a year, or do I? Yeah, 365. I don't want to go to a month because every month is different and I can't do 12 months in a year. That'd be all goofy. So I just go from days to the year. So if I put the days on the top, I know they'll cancel. My hours have canceled. I've got a year on the bottom, and 1 year is 365 days. 0.25. Well, we don't need that in there. So now I have a bunch of fractions that I'm multiplying. And if you look, it's 1 all the way across the bottom, isn't it? So get your calculator, go, 300,000 times 60 times 60 times 24 times 365. And that is how many kilometers light travels in 1 year. No. Because that would be how far it would go in 365 seconds. You have to write these things out like this.
Oh, because that's the amount of time.
So, Phoenix, what do you have?
Yeah, wait, so I'm just wondering, how do we, like,
All the equations.
do we times 300,000 times 60 times 60 times?
Yeah, because this is all the multiplication of fractions. That's what unit conversion does. Say that again, Selby?
1.65564E13.
I got
I got
9.
a
Yeah, okay, hold on, I want somebody who's got a 9.
9.46.
Times 10 to the
12th.
12th power.
608. 608.
Oh, we don't need all those. Okay, it's good enough to say it's 9 or 9.5. Times 10 to the 12th. E12 means times 10 to the 12th power. Why does it say E? Because that's the calculator's way of saying that the number you have in front of you is multiplied by 10 to that power. Exponent. So it's putting it in scientific notation. So you have 9.4 and then there's a whole bunch of digits and they're not that important because this number here is going to be times 10 once, twice, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. So that's how many kilometers it is. Now, 10 to the third is 1,000. 10 to the 6th is million. 10 to the 9th is billion, and 10 to the 12th is 12. So it's about 9.5 trillion kilometers in 1 light year. Okay, so let's do that again. If I get rid of this, and I get rid of kilometers, and I say we're going to use 186,000 miles, because that's how many miles a second light travels, you're going to have a smaller number, right? When you multiply? Because miles are longer than Ks. But you still multiply all this out. So somebody? Multiply when? 186,000 times 60 times 60 times 24 times 365 equals?
5.8656696.
Okay, I just want this right here. And that's 10 to the 12th power again. So it's about 6 trillion miles that light travels in 1 year. 6 trillion. The closest star is 4.4 light years away. The closest star is roughly 25 trillion miles away.
What would they use light years for measurement?
4 years for that.
What do they use light years for?
Why do they use light years for measurement?
Why do they use light years for measurement? Because the distances are so great in space. If we said how far it was to the nearest star and we had to use that number in any kind of a calculation, 25 trillion, and it's just, and that's the closest star.
How many light years are in the sun?
It's only 8 minutes away.
Wait.
8 minutes of light traveling to get to us from the sun. The light from the sun gets here in 8 minutes. The light from the next closest star gets here in 4.4 years.
That doesn't make any sense. That's really different. So the star so
You
far
just see
away.
them at
The
night.
star is so far.
But
Yes,
that-
you
no,
see
wait,
you
you're
see them at light.
You see them in 4 years ago. That's what the star looked like 4 years ago.
Yeah, 4.4 years ago. You gotta work your math better, okay? Yeah, and that's the closest star, you guys. That's the closest star. If you could take the entire Milky Way galaxy, well, besides the sun, yes. But if you were to take the entire Milky Way galaxy and put it into a scale where it was a meter by a meter in size, on the best night, on the clearest night, so that a meter by a meter is what? It's as big as roughly this. If we took the Milky Way galaxy, which is one of billions of galaxies, and you looked on the clearest of nights, That's how far you get to see. The rest of it you don't see.
Wait, what did he see?
Right here. That's what you get to see. The size of a dime. That's how many of the stars of the whole Milky Way you get to see.
What is the meter by meter?
If the Milky Way galaxy, the galaxy that we live in, was squeezed down to 1 meter by 1 meter, scale size, the amount of it that you get to see is right here.
Not a whole lot.
Not a whole lot. And then you have to remember that there are billions of stars in here, and there are billions of galaxies like this. And then here's the really wacko part. If this is the Milky Way galaxy, the next closest galaxy would be in Anchorage at this mapping scale.
That's pretty
And
far.
in between, there's nothing. What's in the center of the
We
galaxy?
don't know.
Oh, they think there's black hole in there, but why is it so light? That's just a rendition, that's an artist rendition of what it probably looks like from a distance. We've never been out there looking in, but that's what we believe it to look like. Yeah, we only see this much. Our solar system is smaller than a pinprick in this.
How can they tell even vaguely?
What's that?
How can they tell even vaguely?
Mostly because of the work of Hubble,
Wait,
which you hear about from time to time, because Hubble does a lot of really cool mapping. So, anyway,
wait,
that's
I have a
my
question.
little thing for today, and then we're gonna move on. Yeah,